Hey guys, this is Ed Revolusi here, and today we'll be taking a look at a subtopic from Form 4 Chapter 3 SPM Physics called the Archimedes Principle. This is a principle that is generally touted as one of the hard parts of SPM physics, so I'll try to explain it to my best ability. Now, the calculation part is not that hard for students. The hard part comes when the questions revolve on the understanding of this principle. So, this whole principle, why does it exist? Well, it's based on these two phenomena, okay? Now, here you can see a heavy ship. Its mass is 500,000 kilograms. And here you can see a coin. Its mass is only 50 grams. So the ship is obviously way more heavier than the coin. So, the question comes from, how can this heavy ship float while this light coin sinks? This is the main question. And this is explained through this principle, which is the Archimedes Principle. So how does that heavy ship float? That's what we are trying to find out today. So, the main definition for this principle that you find in textbooks and all that, well, this you need to memorize usually, as it usually carries like 1 or 2 marks in essay questions or structure questions. So just memorize it, okay? So first you memorize it, then you try to understand, okay? So when an object is partially or completely immersed, that means you put it in the water or the fluid, whatever fluid, put it inside. Into a fluid, a buoyant force, okay, this is what we are trying to find out here, the buoyant force equivalent to the weight of the fluid displaced. That means, I'll show you here in a while, what does displaced mean, acts on the object, okay? So here's a Eureka can, and here's like a beaker, and here's like a weighing machine, okay, it measures the weight, okay? So, when you put an object into here, let's say we put an object into here. If you put this, as you learn in Form 1, the volume of the water will be displaced, as when you put something inside the water, its volume will increase, okay? So the water will go into here and it will fall here, okay? Now the weight of this liquid here is the buoyant force acting on the object. Buoyant force is always opposite of weight, okay? Okay? So the buoyant force equals to the weight of this thing, the amount of liquid in this beaker, okay? So, if an object is able to float, let's see, if an object is able to float, like it doesn't sink, it just floats, that means its weight is equal to the buoyant force. If an object sinks, it's like going down, it's going down and now eventually it will stop going down. So when it goes down and it sinks, that means its weight is more than the buoyant force. Okay? Can you guys understand that? So if the object sinks, that means the weight of the object is more than its buoyant force. So technically, when an object is denser, that means it's more heavier, it has a higher likeliness to sink, as it might not displace enough water, okay? So the main formula in this chapter, this subtopic, is F equals to mg, which you always see in the books. The mg refers to the weight of the liquid displaced, and this is buoyant force, okay? But usually, when you're doing calculations, you use this version of the formula. I'm pretty sure your teacher would have taught you also, which is buoyant force equals to rho Vg, okay? The rho V comes from the mass, okay? We use the density formula. So, if you want to know what's going to happen, like if they ask you to ramalkan, predict a situation, all you have to do is just look at the values here. most phenomena you can understand through the formula of the principle itself. So yeah, now we'll look at how to apply that in a while through this common question. Okay, so this question usually tests your understanding on this subtopic lah. So here's seawater and river water. Okay, and here's the ship. The ship has sunk a predefined amount, okay, and now it's floating. So now technically its buoyant force that's acting on this ship is equal to the weight of the ship. Now assume that the weight of the both ships that I'm going to draw now is the same. So the buoyant force needed to keep them afloat is also the same. Okay, you can understand. So the buoyant force that needs to act on both ships to make it afloat is the same. Okay, so what's the difference between seawater and river water? Okay, seawater has a lot of salt. And we should call it hard water. And river water doesn't. Okay, it doesn't have a lot of salt. So when there's a lot of salt, the water is more dense. Use the formula rule. More dense. So this doesn't have any salt. No salt. So compared to this, it will be less dense. Okay, so now since this is more dense and this is less dense, okay, river water is less dense. So, and the buoyant force of these both situations is the same. Both situations, they need the same amount of buoyant force as the ship's weight is the same. So, how much will this ship sink? Will it be the same, or will it sink more, or will it sink less? Okay, so to answer this question we have to look back at the formula again. Okay, F equals to rho, which is the density of the liquid, V, volume that is displacing, like this one is the volume is displacing, and G, which is the gravitational constant, is always the same. Okay, 10 meters per second square. So since the buoyant force in both these situations is the same, okay, buoyant force in both these situations, situation A and situation B, is the same. So we compare the both formulas. Okay, rho Vg in the situation A equals to rho Vg situation B. So these both are the same, so you can cut them off. So technically they are the same, right? So when the density increases, the volume, should it decrease or increase? It should decrease. When the density decreases, the volume needs to increase. Let's say I try to put it in mathematical terms lah. So this is, let's say 3 and this is 2 equals to 2, 3. So here the density is less, the volume is more. The density is more, the volume is less, but the product is always the same. Okay, I hope you guys can understand that. So when I draw this ship, it will sink more. Pardon my drawing skills. So this will sink more. You can see here, it sinks more. So this is the basic understanding of it. The buoyant force acting on them is the same because they are floating. So the buoyant force is the same, but the density is different. So you have to use this understanding, and so you will know. Okay, since the product is all the same, 6 6, you have to change accordingly to get the same amount of product. Okay, another thing that gets thrown around in this chapter a lot is the submarine situation and its ballast tank. Okay, now the thing to understand this is the submarine, its shape is always the same, right? It's always the same. It's always the same. The shape is always the same. So the volume it displaces in any situation of water displaced is always the same. The thing that this ballast tank do, the ballast tank, okay, ballast tank, this ballast tank pumps water in and out to change the weight of submarine. Sorry. The important word is the weight. Okay? So the volume is always the same, but it changes the weight of the whole thing. So let's say the submarine, when the ballast tanks are empty, it can float. Okay? So the buoyant force is equal to the weight of the submarine right now, okay, with the ballast tanks empty. So now the submarine pumps in water inside, so water goes inside the ballast tank. Okay, water goes inside the ballast tank, so the weight will now increase, right? So the weight of submarine increases, and thus the submarine will start to sink, because the weight will exceed the buoyant force. So there'll be more weight than the buoyant force. The buoyant force will already stay the same because the volume of the submarine stays the same. Okay, so the weight will keep increasing, and so it will keep sinking and sinking until a point where it will eventually stop. Okay, so that's all for this subtopic. It's called the Archimedes Principle. Now a brief overview would be this subtopic involves the flotation principle a lot also. So the flotation principle is this flotation principle. You have to know this. When the weight of the object is equal to the buoyant force, then it will float. You have to understand this. Once you understand this, then this topic can be easily understood. Okay, and remember, the buoyant force is always opposing the weight of the object. So the weight of the object goes down in the arrow you see here. Let's see here. The weight of the object goes down, mg, right? So the buoyant force will go opposing this. So that's all, I guess, for this subtopic we call the Archimedes Principle. Thank you guys for watching, and see you guys in the next video. Please comment down below on any topics that you regard as hard in Form 4 or Form 5 physics, or any other science subject if you guys want. I'll try my best to make a video for that. Thank you guys for watching, and please do subscribe. Peace.